identities. I'm sure you will get one of those in your exam tomorrow. We weren't going over a whole lot of matric work. We had done that previously when we were doing our boot camp, etc., but I hope this will be useful to you. I'm sure you'll have an identity to prove. You're always given one in any paper too anyway. Okay, so let's jump straight in. Just some tools that we can use when we want to prove identities. All right, so an identity is not an equation. Okay, so you cannot treat it like an equation. In an equation, we're allowed to do something to the left-hand side, provided we do the same thing to the right-hand side. An identity doesn't work like that. We are either working with the left-hand side or with the right-hand side. So we have to split them apart. So we cannot work with the left-hand side and the right-hand side simultaneously. Okay, so the way in which you set your work out is also really important. So first things first, you need to split the left and the right-hand side. Okay, do not forget about your grade 11 identities. So your tan identity, so tan theta is sine theta over cos theta, and your square identity, sine squared theta plus cos squared theta is equal to 1, because those get used as well. Because you are in matric, you must expect double and compound angle formulae, so be on the lookout for those at all times. The other thing that you need to be able to do so often in trig is the adding and subtracting of fractions. Okay, so remember, when we add and subtract fractions, we have to have a lowest common denominator. So that comes up a fair amount as well. And then the other important thing we always need to bear in mind is that we have to factorize. Okay, so you cannot cancel terms, you cannot cancel over plus and minus signs. So you have to factorize. If you've got 2 terms at the top and 2 terms at the bottom, or 3 terms at the top and 2 terms at the bottom, you will need to factorize before you can cancel. You cannot cancel terms. So be on the lookout for taking out a highest common factor, dots or difference of 2 squares, trinomials, those are the most common. And then on some very rare occasions, you might see grouping or sum and difference of 2 cubes, but hopefully nothing more hectic than that. Okay, so the compound angle and double angle formulae are here. Let's have a look at the very first example. Okay, so in this example, we have got on the left-hand side, we have 1 plus cos 2a over cos 2a. All right, so based on our double angle formulae, can anybody make a suggestion as to what I could replace cos 2a with? What should I replace cos 2a with? I want to try and cancel out the 1. So this 1 over here, I want to try and get rid of it. This 1 here. If I want to get rid of that 1, what should I replace cos 2a with? Suggestions, Matrix?
Ma'am,
Yes, Bonga.
can't you replace it with 2 cos squared a minus 1?
Lovely. Okay, perfect. So 2 cos squared a minus 1, that'll get rid of that. And now I've got cos 2a over here. All right, lovely. So now the ones are going to cancel out. That leaves us with 2 cos squared a at the top. Sorry. And that leaves us with cos 2a at the bottom. Now, I haven't done anything about the cos 2a at the bottom. What do you think I should do with that? How should I rewrite the cos 2a at the bottom? Any ideas? Does it matter at this point? What do you guys think? What do you think, Matrix?
Hi,
Very
ma'am.
high, Lorata. What would you do?
I think ma'am use the compound formula.
Compound formula. Okay, but I
Yeah.
can't use, but I don't have a compound angle here. So I don't have cos A minus B or cos A plus B or sine A minus B or sine A plus B. I've got a double angle. I've got a cosine double angle. I've got cos 2A.
Okay.
Okay. All right, so I tell you what, let's see if we leave it as cos 2A for now. Okay, I can't simplify what I've got here anymore. All right, because I would have two terms at the bottom and one term at the top. So in a situation like this, what I can do is I can go and work with the right-hand side separately. So I'm going to now write right-hand side. And here I've got tan 2A. And at the bottom, I've got tan A. So any suggestions? What can I do with tan 2A? Or what should I do with tan 2A?
Ma'am, can't you make that sine 2A over cos 2A?
Beautiful. So sine 2A over cos 2A. All right. And then the easiest thing for me to do with the tan A is rather than putting it underneath as a complex fraction, I'm going to write it here on the side. Okay, so divided by tan A. All right. So when I have fractions, I can tip in times. All right. So what I'm doing here is I'm dividing it by sine A over cos A. So let's tip in times. And then we can take it from there. Now, I can't cancel anything because sine 2A and sine A can't cancel, right? So what would you do now? Okay, you've got double angle formulae that you can manipulate. What would you do with the sine 2A? How would we write that? Sine 2A can only be written in one way, Matrix. Okay, so it's just going to be written as, that's it, 2 sine A cos A, cool. All right, so I'm going to do that. And now that I've got to this point, now I can start canceling things. All right, so I can cancel because I don't have any pluses and minuses. So I'm not canceling over plus and minus signs. So I'm going to cross out that sine A at the top with that sine A at the bottom. Okay, that can cancel and look there. Okay, in my next step, after I've done that, I would end up with 2 cos squared A over cos 2A. All right, and now the left-hand side equals the right-hand side. Are we happy with that, Matrix? Any questions? Are we all good? Thumbs
Yes,
up, thumbs down.
we're only seeing steady so far. Okay, I see some hands are
Okay,
coming on the
all
chat.
right,
Thank
that's
you, my
fine.
people. I was
All
about to
right,
panic.
good. No, that's okay. We're all still alive.
Nice, guys.
Okay, good. All right. So remember, we're doing ones that are difficult on purpose. I'm not doing easy ones with you. I'm doing slightly more difficult questions with you guys. All right. So now here is one for you to try. Okay. So tan A plus cos A over sine A equals 2 over sine 2A. You guys are going to do that one by yourselves. And there I've got the compound angle formulae here for you. Let's see what you do with this one. And again, when you're done, please just say done in the chat.
We are giving it a try, my people. We have all that we need there in a little box. If we can follow all those rules and try to use them so that we can reach to our point that we want. If you are done, I know that you still need more time, but remember to put done on the chat. Like this, we can be aware that you're already done with the proof.
And of course, if you're struggling, don't be afraid to say so. Yolanda and I are here to help you. Okay. So there's a bunch of dones, 2 dones. Cool. All right, so I'm going to start writing the left-hand side out, just in anticipation of you guys finishing. Cool. Right, so I'm just going to wait 1 more minute and then we can start with the answer. right, there we go. Okay, so I'm going to do the easy part. All right, the easy part is writing tan A as sine A over cos A. One of you is going to tell Yolanda and I what the next step is. What would you do after that? After you've written tan A is sine A over cos A, what is the next step? Can anybody tell us what is the next step? That's it. Well done. Yes, Lucidi. Yes, Keithlin. You've got to find an LCD. Beautiful. Okay, so in this case, we would have to multiply sine A and cos A together to get our LCD. Okay, so our LCD is going to be cos A sine A or sine A cos A. So what you've done basically is you've multiplied that by sine A. So you've got to multiply this by sine A. You've multiplied this by cos A. So you've got to multiply this by cos A. So the idea here is exactly the same as when you're working with normal fractions. So imagine you have 2 over 3 plus 1 over 5. Your lowest common denominator would be 15, right? Which is 3 times 5. So here you'd have to times that by 5 and that by 5, and this by 3 and that by 3. It's exactly the same idea. Okay, except we're working with sine A and cos A instead of with numbers. That's it. All right, so our first term in the numerator is going to be sine squared A. Our second term in the numerator is going to be cos squared A. Okay, so again, I'm doing the easy bits, you guys are doing the hard bits. Now what? What are we going to do next? That's true. Good, Jordan. Perfect. The top is equal to 1. Lovely. And the bottom is still cos A sine A. All right. Now what do we do? What's next, Matrix? You can do that. Absolutely, Lesejo. You can work on the right-hand side. So on the right-hand side, you've got 2 over sine 2a. So on the right-hand side, you've got 2 over sine 2a. Is there anybody that didn't work on the right-hand side? Pinga. 1 over 2 times 2 for the denominator. Pinga, I think what you are telling me is what I was going to suggest as an alternative, but I'm not sure if you and I are saying the same thing. There is another way to do this, guys. You don't have to work with the right-hand side, but let's talk about that afterwards. Okay, so you said work on the right-hand side. So working on the right-hand side, there's obviously nothing that we can do with 2. What are we going to do with sine 2a? Okay, so we're going to make it into 2 sine A cos A, quite right. And now, because we don't have any pluses and minuses, we are allowed to cancel down. So we can say 2 divided by 2 is 1, and that is going to leave us with 1 over sine A cos A. All right, and now you are allowed to conclude that the left-hand side equals the right-hand side. Okay, so as long as you split the left and the right, you can work with them separately, but you cannot work with them while they are still equal to one another. All right, very important. Okay, well done. Let's go and have a look at some slightly more difficult questions now. Before we do that, I just want to point something out to you that you may or may not be aware of. Did you know that you can multiply this fraction 1 over cos A sine A, did you know that you can multiply it by 2 over 2? Because when you multiply something by 2 over 2, it's 1, isn't it? When we multiply fractions, we multiply tops with tops, bottoms with bottoms, and we would end up with this. Okay, so this is just an alternative way of doing it, and that would give you 2 over sine 2A. All right, so just as an alternative to working with the right-hand side, that is allowed. Bonga, if you do, it's just going to make your life so much easier. But no, they are given to you. Right, you don't have to know them off by heart. Okay, if you can detach your formula page and then just take it with you instead of having to flip backwards and forwards. That'll also just help to save a little bit of time. Okay, all right, so if there aren't any other questions, everybody happy with that? Thumbs up? Thumbs down? Cool beans. Okay, so let's jump into something that is a little bit more difficult. Okay, so these questions that I've given you are not the easiest, okay, but you have to try them because you're going to get things like this in your tests or an exam. Okay, so I don't want you to do question 2 just yet, all right? I want you to look at question H or question I. Question H or question I. Those are your 2 options at this stage. So you are either going to try H or you're going to try I. If you do H really quickly, then do I. But you are going to pick one of these 2, either H or I, and you are going to try one of those 2 questions next. What I can do, sorry, I didn't think about this. Maybe this will just help to block things out a little bit. Okay, so either H or I, and you are going to try one of those. What I will do, just put that over it just to not distract you. Let me go and grab the formulae. Sorry, guys, just get those. There we go. All right, so either H or I, please matrix, off you go if you haven't started already. Oh, Tsegofatso, I'm sorry. I know I'm pushing you guys a little bit tonight. Tsegofatso, start by squaring the binomial. Okay, so for example, let's say I'm going to just change it a little bit. Let's say you have cos A plus sine A and it's squared. Remember, that means the bracket multiplied by itself. So you've got cos A plus sine A multiplied by itself. Do FOIL. So that will give you cos squared A plus cos A sine A plus sine A cos A. So that would give you 2 sine A cos A as your middle term plus sine squared A. Do that first. Okay, Ntlafatso? Don't worry about theta over 2. Theta over 2 is the angle. So just like I've got A in my example over here, you're going to have theta over 2. Okay. So there's your hint. Does that help? Ntlafatso? Sihawu, does that help? Okay. All right. So remember, when you are working with trig expressions, it's like algebra. Okay, cos A is a variable like x is. Okay. No, because if you have cos theta over 2 times cos theta over 2, Sihawu, that's cos squared theta over 2. Okay, so nothing's going to happen to the angle. Okay, it's the ratio that's being squared, not the angle. Okay. Again, if you're done, say that you're done. If you're stuck, don't be afraid to ask. Again, so if you're done, you can just say done in the chat. I'm not trying to rush you.
So y'all are doing a great job. So please make sure that you always are alive and showing us some lifeless. No, not lifeless. My English is also run out on top of that. You guys are doing really great. I love this section, actually. I really, really love it. I hope you guys love it too. It's good to get something right because immediately you can give yourself marks, you know? So,
I hope I haven't made these too difficult.
no, I think it's perfect. I think it's really
But
perfect.
I think they needed the challenge.
Yeah, you see, and Tafato
Okay.
is like, I'm done. You see,
All right.
they
And
also are
Tafato.
strong enough. Yeah, strong
Okay.
enough to do it, which is great. Because to be honest, in this section, they do have some hard ones also.
Oh, definitely.
Normally on
Yeah.
the exam. Yeah,
That's
they
right.
don't normally put something that is too obvious.
No. This is
Yeah.
meant to be difficult.
Yeah.
Matrix, can I go through question H with you? Or do you want a little bit more time?
Now is that time where you're showing your aliveness, huh? Either by putting thumbs up on the chart or some reaction like this, we can know that, okay, you're still with us. Let's go, my people. Do you want Teacher Lee to just go through it with us, or you want to do it yourself? So first you put thumbs down if you want to do it yourself, thumbs up if you want Teacher question I. Are we not doing question J though first? So guys, if you finish with H, sorry, not J, with
Okay,
H,
question.
yeah, please make sure that you put on the chat done, because I don't. Yeah, we didn't say they should do all of them at once, right? Or should
Yes.
they
No.
do all of them at
I
once?
just wanted them to do either H or I, but not both of them at the same time.
Okay.
All right. So Tando, it's supposed to be, and I'm going to show you what happens in question I right now. I is a sneaky one because it is the exception to the rule. Fine. Okay, so let's run through H and then we can talk about what happens in I. Okay, so after I did this on the side over here, hopefully that helped you to be able to proceed with question H. So you are squaring a binomial. So you would have ended up with, if I can go straight to the trinomial, you would have ended up with cos squared theta over 2 plus your middle term would be 2 sine theta over 2 cos theta over 2, and your last term would be plus sine squared theta over 2. Everybody should have been able to do that step over there. Okay, so I've squared the binomial. So now your sine squared theta over 2, your cos squared theta over 2 plus sine squared theta over 2, that is your square identity. So sine squared theta over 2 plus cos squared theta over 2. You don't actually have to do this step. I'm just putting it in here. This is the 1. So that's where the 1 comes from, right? So we've got 1 plus 2 sine theta over 2 cos theta over 2. And this is your sine double angle. Okay, so it is expanded. Okay, it's like this. So what we want to do is we want to do this with it. We want to write it as sine 2a. So not that you need to show this step either. This is not one of the steps you need to show, but this is what I'm doing. So I am doubling my angle. Okay, and remember my angle is theta over 2. Okay, which is why that 2 divided by 2 means you're going to end up with 1 plus sine theta, and it's equal to the right-hand side. Okay,
This is
who got?
beautiful.
Oh, good.
Such a
Who got that?
beautiful math.
It is, isn't it? All maths is beautiful, isn't it, Yolanda?
Yeah,
It
it's
is.
really beautiful.
Okay. How did that go? Did you get H correct? Yes, no, thumbs up, thumbs down. How did H go? Were you
I
on the
see
right
some
track?
celebration.
Are there people happy? Good.
Looks like it.
All right.
Okay, guys. Then you were panicking for nothing, you see?
Okay.
Nice.
Very easy, yeah. Yes, Keithlyn, you do. What's your name?
Somi. You can call Somi also.
Somi will be much easier. Sorry, please
Yes.
excuse my pronunciation, Somi. Yes, you can, because the idea is this is what you are doing. You are it's a double angle, isn't it? So if you have got the sine of 2 times and then your angle is theta over 2, when you times 2 with theta over 2, the 2 cancels, and that's why you're just left with sine theta. Okay, Somi. And I think there was one other person, Keithlyn, hopefully same story. Okay. All right, good stuff. Okay, so that was that one. Let's go and have a look at this guy over here. And what throws us with this particular question I is this sine 4 theta, isn't it? Okay, that's what throws us. So, oopsie, I should have left-hand side equals. So we've got sine 4 theta minus sine, what kind of word is that? Not the one that we want anyway. Okay, and then here we've got sine 2 theta, and then at the bottom, we've got cos 4 theta plus cos 2 theta. All right, so this is what we need to do with this question, right? We are working with sine 4 theta and cos 4 theta. We are treating 4 theta as the double angle. Right? Allow me to proceed. Okay. So when we see sine 4 theta, we can write that as 2 sine 2 theta cos 2 theta using our sine double angle formula minus sine 2 theta. In the denominator, if cos 2 theta occurs with cos theta, the best thing to do is write cos 2 theta as 2 cos squared theta minus 1. Okay, so what I'm going to do is I'm going to write cos 4 theta as 2 cos squared 2 theta minus 1 plus cos 2 theta. Now, your teachers and me, all of us, are guilty of saying to you, when you see sine 2 theta, you write it as 2 sine theta cos theta, isn't it? So that's what you always think you should do. I is the exception, all right? Do not simplify it anymore. Leave it like this, and now you are going to factorize. Okay, if you now expand your double angles, and I'm sure this is what happened to you, you end up with something 10 miles long and it's a total, complete and utter mess and you don't know what to do with it. So don't expand any further. At the top matrix, we can take out sine 2 theta as a highest common factor. At the bottom, we've got a trinomial if we can just get it into the right order. So what I'm going to do is I'm going to leave the numerator as it is. So as 2 sine 2 theta cos 2 theta minus sine 2 theta. And then at the bottom, I'm going to leave the squared term at the front. So 2 cos squared 2 theta. I'm going to put the plus cos 2 theta in the middle, and I'm going to put the minus 1 at the back. So at the top, we are going to take out sine 2 theta as the highest common factor. That's going to leave us with 2 cos 2 theta minus 1. Okay. At the bottom, we have a trinomial. So I'm going to factorize my trinomial. So I'm going to have 2 cos 2 theta at the front of that bracket, cos 2 theta at the front of that bracket. Now I need 1 and 1 to give me 1. I've got plus 1 in the middle, so that bracket needs to be a plus, and that bracket needs to be a minus. By the way, be very careful, all right? When you write cos squared theta, or if you write cos 2 theta, this 2, the square can end up looking like this. Okay, they're not interchangeable. So be extremely careful in trig when you are working with double angles, that your squares don't look like double angles and your double angles don't look like squares. Okay, so be very, very, very aware of that when you are working in this section. Okay, now that you have factorized that bracket at the top with that bracket at the bottom. All right, so now let's go and reassess the situation. At the top, we have sine 2 theta. At the bottom, we have cos 2 theta plus 1. What do we want on the right-hand side? We want tan theta. So essentially, this is probably going to come down to sine theta over cos theta, okay, which will give us our tan theta. Now we're going to expand further. So at the top, we would have 2 sine theta cos theta. And we want to try and get rid of the 1. Okay, so if we replace cos 2 theta with 2 cos squared theta minus 1, we can get rid of this 1 at the end. So I'm going to rewrite that as 2 cos squared theta minus 1 plus 1. So now finally matrix, we've got 2 sine theta cos theta. In the denominator, we have 2 cos squared theta. We only have one term at the top, one term at the bottom. We're not cancelling terms. 2 divided by 2 is 1. Sine theta can't cancel with anything. Cos theta goes into itself once, and it goes into cos squared theta, cos theta number of times, essentially. And there we go. We have sine theta over cos theta, which gives us tan theta, which is the right-hand side. What do you guys think of that? Any questions? I'll go back up again in case you want to do screenshots. And then back down again. Keithlin, oh, I'm sorry. I'm sorry. Was this just too difficult? Does it make sense though?
Ma'am.
At least we're doing it now. I'm so grateful
Yes.
because imagine getting this in your exam and you're not getting it with Teacher Lee. Bonga has
Yeah.
a question.
Yeah, go for it, Bonga.
Ma'am, could you just go back to what the original question looked like, please, so I can take a
Yes,
picture?
sure, with pleasure. There it is. It's question I. Okay. All right, so this is a difficult question. Right, but the trick is not to expand everything to and work in terms of a single theta in the beginning. Okay, so first work in terms of 2 theta, factorize, and then simplify to theta after that. All right, let's do another one. Cool beans. All right, so remember, guys, you can also put this onto the Watobe Wizard. It should be able to help you. Again, if you want to watch this video and just come through to the last part and have a look at I, you can look at that again. But yes, we've got to do questions like this together because these are the kinds of things that they're going to give you in the exams. Okay, the exams, unfortunately, are not going to be easy. All right, let's do another one. Let's see if we can fit another one in. What about question J? So again, this is a bit of a challenge. Let's have a look at question J. J is actually not as bad as it looks. What I'm going to do is I'm going to rub this out. Okay, so let's try J a little bit together and a little bit by yourselves. We haven't got an awful lot of time. So let's see if we can do it in the bit of time that we've got left. Okay, so on the left-hand side, matrix, we note we have got sine 4 theta. Okay, so what are we going to do with sine 4 theta?
Ma'am, can't you say 2 sine 2 theta?
Exactly, lovely. 2 sine 2 theta cos 2 theta. Absolutely. Oh, gosh. Sorry. 2 theta. Anything else that we can do with it? Can we do anything else with it?
Is it possible for us to scroll down those identities?
Oh,
Those
yes.
ones that
Sorry,
you
I just
normally give to us?
sorry. Yes.
I
Sorry,
feel like I'm
matrix.
spoiled. So now I was like, where are these things? Because then I couldn't
Sorry,
see them
they're up.
anymore.
No, they're here.
Guys, I hope you
Sorry,
have a picture. At least you are working with this in front of you because that's the only way that you can practice it until it's in your head. Okay.
In fact, if I was you in my Watobe book or whatever you're writing in for Watobe, I would get a formula sheet and just stick it in, not stick it in as in like with glue, but just put it into the book so that it's always there with you.
Yeah.
And then you can refer to it easily. Okay, So agreed, we can simplify this a little bit more, right? Because we can write sine 2 theta as sine 2 sine theta cos theta, right? And cos 2 theta can also be written in another way. So if I leave it as cos 2 theta for now, we can decide what it is that we want to do with that. Okay, you can see this starting to emerge here. Okay, because if you've got 2 times the bracket, you'd get your 4 sine theta cos theta. Can you see that matrix? So let's
Hey
just leave it
guys,
like
is it clear?
Is that clear to everybody?
Okay, at least Keith is agreeing with us. Lucero is also saying yes,
Okay.
ma'am.
All right. So now we need to decide what it is that we're going to do with the cos 2 theta. Any, excuse me, any suggestions?
And please don't leave, guys. We have the poll to do.
Absolutely. I mean, if we've got this sine cubed theta here, how would we get sine cubed? It would have to be sine squared times sine theta, isn't it? So let's go with 1 minus 2 sine squared A. Is everybody happy
Theta.
with that? Oh, sorry, theta. Ugh.
Lisa did
Yeah.
the rules, my girl, the rules. Check the rules.
Okay, Lesedi, these are all just your double angles. Okay, so we've written sine 2 theta as 2 sine theta cos theta. We've written cos 2 theta as 1 minus 2 sine squared theta. All right, so now what I'm going to do is I'm going to get rid of the round brackets. That's going to give me 4 sine theta cos theta. I'm keeping the square brackets. And now I'm going to do distribution. Okay, just like we did in grade 8. Factor on the outside multiplied by the first term. So that would give me 4 sine theta cos theta. And the factor on the outside multiplied by the second term. So that's where the 4 times 2 would be 8. Sine theta times sine squared theta would give us the sine cubed theta. And then we would have the cos theta at the end. Okay, and
That's
then
so
it would be
cool.
equal to the right-hand side. So it's actually not as bad as you think. It looks dreadful when you first look at it, but it's actually really not that bad at all.
Yeah, and
Okay.
playing with the rules, like playing with the identity that they
Yeah,
got.
you need to
they
know your
got.
identities so well. You need to know your identities so well in order to be able to yeah, just know, and that's just it with trig. You know, a lot of it is, you know, try something and it doesn't work, or try something else, you know, rewriting things in different ways. But yeah, make sure you know your identities really, really well. You need to be able to recognize them as well as manipulate them.
Yeah.
All right, so that was a little bit of a challenge. I hope you enjoyed the challenge this evening.
Well, I really found it awesome teaching you.
Good. I'm so glad, Yolanda. I just hope the the matrix agree with you and they enjoyed it too.